Hi, today's problem is evaluate division. So basically in this problem we are given an equation array, a value array and a queries array. So from our input equation, it represents that if we are given two variables a and b, then the value for that operation a by b is equals to 2 and b by c would be 3, and we are later given a query a in which we have to determine what is a by c, b by a and a by e. Okay, so how we can approach this? We would take it as a graph problem. So for example, a by b can be represented from a to b, say the value is 2. Okay, so and b to c, the value is 3. So if we don't have a direct path, then the value would be from a we can go to b, and from b we go to c. So from the path to a to c would be 6. That would be 2 into 3, 6. Okay, and similarly we can construct a graph for this. So from a to b, if there is a path, then for b to a would be 1 by 2. Similarly, if b to c is path, then c to b would be 1 by 3. Okay, and if in case there is no path, so for example if we want to go to a different variable d, okay, and we don't have any path, so we have to return -1. So for example, if the query is from a to b, we have to find a path. Since there is no edge which connects to d, then we have to return -1. So this is the basic intuition. So first what we'll do is our code has basically two parts. First is build the graph, and second would be DFS function. So for build the graph, what we'll do is okay, so we'll use a collections default list. Okay, we are using default list and instead of a Python's dictionary, because when you use Python's dictionary, if we use a query which is not present in the dictionary, then it will throw an error. So to avoid that, we are using default list. So for each value in equation, each value pair in equation, we are just either creating a graph like as discussed previously. For a and b, from a to b we have a value 2, and from b to e it would be 1 by 2. So similarly we are creating a graph here. Okay, and we could see that graph here. We can try it out. So yeah, so our final graph would be similar to like this. So for x1, suppose they are given x1, x2. So from x1 to x2 there is one path, okay, 3, and from x2 there is x1. So similarly we have created a graph using the input which we have provided. The next would be to create a DFS function. Okay, so for each query we have to append the answer, like what would be the value for that particular pair. So for example, from a to c we have to append the answer in floating terms, and if in case if it's not possible, we have to append -1. Okay, so for each value and pair we will just iterate to the query a and b, and we'll call a DFS function. Okay, and we are passing to the variable three things in that DFS function. One would be a, which would be the first argument, b would be the second argument. Okay, for example a and c, and the set which we will be using to keep track of the visited nodes, which will come later on. Okay, so this would be the DFS function. So first, if in case we'll first search if the value of x or y is present in the graph or not. So if it is not present, then it would be unable to reach to that point, right? So if in case it is not present, we will directly return -1. Then we'll check for value of x if there is y present in the graph or not. For example, let's say the argument 1 is x1 and argument 2 is x2. So if in case we are searching if x2 is present, then there is a path directly present, so we will return that value. Okay, and if in case it is not present, we have to iterate through the graph, and we are using depth first traversal. So we will try to find all the possible combinations. So like for x1 graph we'll take x2 for example. So for x2 we'll iterate to for x1 and x2. Okay, so first we will add in visited of I. Okay, and we'll iterate to the graph and we'll try to find if there is a visited path present or not. Okay, if in case, and we'll assign it to a temporary variable. If in case the value, if it returns -1, then we'll continue searching for the next possible solution, and if in case it's not present, then we'll continue searching, and if in case it is present, then we'll directly multiply that current value which it has written to the current node value. So like for example, it is taking 2 to from A to B, it is taking 2, and from B to C it is taking 3. Then the value taken, then the cost of reaching that node would be 2 into 3. So we are doing that, and finally we are if it's not possible, if no node is found, we will return directly -1. So we can just run this. This graph. As you can see, our code is successful. We'll directly submit and check if it's working. Yeah, and it's working. Thank you.